So hello students, today's topic of discussion of our thermodynamics chapter is spontaneity. Yeah. So spontaneity is our topic of discussion for thermodynamics. Okay. So spontaneity means suppose in layman point of view we are discussing or simply what is the English meaning of spontaneity or what do you mean by spontaneity? Simply a reaction or if you discuss the spontaneity in terms of chemical reaction, a reaction or a process which does not require an external agency. Yeah. If we are discussing thermodynamic equations, thermochemical equations, so we have to write the definition of spontaneity or spontaneous process in terms of chemical equation. So we can write here a spontaneous reaction is that which do not require any or who does not require any external agency, so that it can be called as a spontaneous reaction. So write down a reaction, a chemical reaction which does not require any external agency. Agency means force. To complete the reaction. To be completed. To be completed. That then only the reaction is known as spontaneous reaction and the phenomenon is known as spontaneity. Here the reaction is known as a spontaneous reaction and the phenomenon is called spontaneity. Okay, so here any reaction which does not require any external agency to be completed, that is the spontaneous reaction, and the phenomenon of the process is known as spontaneity. Suppose we know generally there are two types of reactions, right? One is an exothermic reaction and endothermic reaction, and various thermodynamics terms we have discussed till now, like entropy, enthalpy, your internal energy, right? So we will discuss here that each enthalpy, decrease in enthalpy is required for a reaction to be called as spontaneous, or increase in enthalpy required to be called a reaction as a spontaneous reaction. Here we will discuss here if for a reaction enthalpy is decreasing, is that condition is enough to call a reaction spontaneous, or if in some other reaction enthalpy is increasing, is that condition is sufficient to be called a reaction as spontaneous. For example, suppose I am writing here half N2 plus half H2 gives rise to NS3, or you can write N2 plus 3H2 gives rise to NS3. Here N2 plus 3H2 gives rise to NH3. Here the enthalpy of reaction is exactly the value is minus 46.1 kilojoule per mole enthalpy of reaction. Similarly, suppose I can write here H2 plus half O2 gives rise to H2O. Here enthalpy of reaction is minus 285 kilojoule per mole. Okay, I have written two equations. One is N2 plus 3H2 formation of ammonia and another is formation of water. Both the reactions are what? Both the reactions are exothermic reaction because del H is negative for both the process. Here enthalpy is in the form of negative, means heat is liberated, right? Heat is produced or evolved. So here enthalpy, we are considering this enthalpy. Enthalpy is negative for both the reaction, and these two processes are spontaneous. It is experimentally observed that whenever the reaction is carried out by experiment, they observe that the reaction is spontaneous because no external agency required for the reaction, and here enthalpy value is negative. So this is one condition. Enthalpy is negative or when the reaction is exothermic, the process we got or the reaction we got spontaneous. What is the graph? This is the reaction coordinate and this is the enthalpy. H is enthalpy. Okay, here this is the product, this is the reactant. And this is the net change in enthalpy, that is del H. We are calculating the del H. Okay, so this value is the del H value. Okay, this much value is the del H value for the exothermic process. This reaction is for what? Exothermic process, or the graph tells about the exothermic process where del H value is this much. Clear? Here we have taken enthalpy in the y-axis, reaction coordinate in the x-axis, and this is the product, value of the enthalpy of product, value of enthalpy of the reactant. So del H means, what is del H? Del H is the enthalpy of product minus enthalpy of reactant. Enthalpy of product minus enthalpy of reactant, you are getting what? This much amount of value. Clear? So this is for this is one condition for exothermic reaction. Let's take another example for endothermic reactions. We will see that is endothermic reaction is also spontaneous or not. Clear? Suppose I can write here half N2 plus half O2 gives rise to NO, nitrogen monoxide. Clear? Nitrogen monoxide. Okay. Or I can write here simply you can write NO, formation of nitrogen dioxide. Okay. Half N2 plus O2 gives to nitrogen dioxide. Here enthalpy of reaction is having value of 33 kilojoule per mole. I am writing again here positive, plus 33 kilojoule per mole. Okay. Similarly, I can write carbon. Here these are in gaseous state. Okay. Gaseous state. Here carbon in solid state plus sulfur, or I can write here 2s in also solid state. You are forming carbon disulfide. This is also these are in gaseous state. Here for this reaction, the enthalpy is plus 128 kilojoule Okay, so in the previous reaction we have we saw that the enthalpy value was negative. That means for exothermic reactions, here the enthalpy value is positive. So these two reactions are what type of reaction? Endothermic reaction. Okay, the value of the reactions are what? Endothermic reactions. And experimentally observed that these two endothermic reactions are also spontaneous. These reactions are also spontaneous reactions. Clear? So we took two cases: exothermic reaction, endothermic reaction. Okay, in both the cases we got they are spontaneous. So is enthalpy is the only condition for a reaction to be called as spontaneous? Now question arises: is enthalpy is the only condition for a reaction to be called as a spontaneous? Because we got the both the cases. Exothermic reactions are also spontaneous, endothermic reactions are also spontaneous. So there must be some another thing or another concept that determines the process or the reaction to be called as spontaneous. Clear or not? Any other factor must be there or is actually there that determines the reaction is spontaneous, whether it is exothermic or endothermic. So let's draw the graph for the endothermic reaction. Okay, similarly this is the reaction coordinate. Reaction coordinate is the enthalpy. Clear? Here the product is the reactant. Okay, here this value del H is positive because this is the endothermic reaction. Okay, endothermic reaction our graph is positive value, and in the previous class that was del H is negative. Clear? So for both the cases we observe that enthalpy we can sum here, right point, enthalpy is not the only factor for a reaction to make it spontaneous. That means enthalpy only, that is not the only factor who determines the reaction to be a spontaneous one. Okay, another condition or another factor must be there which can tell about the reaction to be a spontaneous or not. Okay, so let's get